Okay, so far we have looked at one method on how to do half-life questions. I call it the box method because we draw a lot of boxes in it. There's a second method to do this. It's optional for those of you taking IGCSE, but for those of you taking SPM, you pretty much need to know how to use this method. Okay, let's take a look at this. If you look at this worksheet that I prepared for you guys, okay, scroll down to this is the first one. There's an example. Scroll down to this part here. Okay, the if you take a look at this formula here. Okay, uh, just highlight this formula. This is the formula that you actually need to know for SPM, and if you want to do, if you don't like drawing things in IGCSE, you can take note of this formula as well. So basically just use this formula, and let's try the same questions again. So coming back to question number one. Okay, I kind of regret writing so big now. All right, let's use the formula method. Okay, if you scroll up, the formula is n equals half to the power of x and n naught. So let's write it down. N equals half x to the power of n naught. All right, n naught here, okay, represents the original mass of the radioactive element, original mass, and n represents the final mass or final count or final percentage, whatever. X represents the number of half-life. Okay, we'll get to x soon. Basically, x represents the number of arrows. Right, x represents the arrows here. So what I'm going to do is just watch what I'm doing here. So half x n naught initially at 40. Right, I'm too lazy to write out the million, and we are finally left with 5. Okay, so this will require a bit of add maths because you need to use you need to solve it using log. So 5 divided by 40, and you get 0.125. All right, half x. Okay, you can use any logarithmic solution to solve it. So I'm just going to use base 10, log 10, 0.125 equals to x log 10 base 10, 0.5. Okay, sorry, it's very messy. Log divided by 0.125, sorry, log 10 base 10, 0.125 divided by log 0.5. I'm using my calculator now. So you get x equals to 3. Right? If you look at this number here, 3 is the same as the number of arrows we had earlier. So again, if you want to find a half-life, just take 48 hours. Okay, I'm writing, it's getting even more messy. 48 hours, divide by x, which is divided by 3, and you get 16 hours. So you can use either method, whichever one you prefer. Obviously, this method it requires you to know how to use log base log 10 to do. The other method doesn't. All right, this just saves a lot of space. Let's go back to question 6 and try our equation method. Okay, remember question 6 says that they want you to find how long it takes for uranium from 100% to reduce to 3.125 of its original amount, given that the half-life is 24,000 years. So because I have very big handwriting, let me write in box for question number 7. All right, so just write out the equation. N, which is the the final mass, right, equals to half to the power of x, n origin, which is O, that's what the O stands for, which is the original one. So n is 3.125, and half x is then 100. So just rearrange everything. Log, you can use any base you want, 3125 divided by 100 equals to x log half. All right, just rearrange everything. Okay, put in your calculator. Log 3.125 divided by 100, blah blah blah, divided by log half, and you should get x equals to 5. Right, does this number look familiar? If you count the number of arrows, 1 2 3 4 5, all right, the number of arrows here, yeah, it's the same thing. So 5, in this case, the half-life is 24,000 years. Okay, it's stated here is 24,000 years. So what I'm going to do is total time is 5 times 24,000 years, which should give me 120,000 years.